Okay, hello. So I think I'm online. Stream quality might not be good. So I will check afterwards. YouTube so far is telling me that it's a good connection, so yes, it works. But usually my internet connection is not that good. It might change in a couple of months. Maybe I will try again then. Um, so first off, a couple of disclaimers. I'm not really like it's not a serious attempt to rewrite. Rust people tend to they like to rewrite everything in Rust. So, but I started I wrote a couple of tools also in Python and then in Rust for Factorio, and I kind of started to actually put them together into one crate, one library, which is this. Or actually, let me find my GitHub. So it's on GitHub called Rustorio, and so maybe I should go back a couple of months when I. First of all, Factorio is a game about automation, so I wanted to automate the game. And my first attempt was building CPUs in Factorio, so I can run programs that control the signals in game, the circuit signals. While being a nice thing to do, it's not really fast, so um, I built a MIPS CPU which ran at about like 3 instructions per second or something like that. That's not enough. The next thing is I built a remote which consists of basically one mod or 3 mods in total. The Factorio mod which creates entities so you can interface the circuit network from outside and actually do other stuff. It's basically underlying mod, this remote, allows other mods to expose functions outside the game. So you can actually requests into the game and the mod then handles them. For example, setting circuit signals or reading circuit signals, and then you can write your client application basically in any language you want. I had a Python client. It's not in here. I have to find it. And there's a Rust client. So it's this remote here. So that was a couple of months back when I wrote that to like kind of have an AI for the game in Rust. But I also started. Well, I wrote other tools as well, like for example, manipulating blueprints or generating blueprints. Okay, so my stream bitrate is not good enough. Check that. Yeah, my bitrate is way too low. It says it's good though. I mean, I apologize if quality is too bad. I will just wait until I get better internet. But I can really only check after the stream. This makes sense. If it's worth the effort. Anyway. Okay, so I wrote other tools as well. Blueprint is something I do commonly, like general blueprints. Because you might not know, but blueprints in Factorio are just JSON objects. So it's actually pretty easy to generate your own blueprints. Usually what I would do is in-game create a template and then load that into Python or whatever you want to use. And then, wait, show you the grid format. That's not it. So yeah, it's just JSON. So you can just, so I usually use the template, blueprint, decode it, and then change it around and then encode. That's actually one tool I recently started working on, and which already kind of works, is a circuit compiler, or it's a circuit description language. So you can just define simple circuits in code. Actually not simple circuits, because those you can just build in game. But so this is a clock, basically a decider, combinator, and then it also has kind of like generics, so you can configure the amount of seconds and signals. I won't go into detail. There's actually, if you are interested in that, go to Factorio circuits. There's a description a little bit about how to use the compiler and how the language works, although it's not up to date because the language will change. It already changed. It will change more. So please don't tell me that it doesn't work, because I can't keep updating this document for every change I make. It's like very much work in progress. I can point you towards, if you really want to know how the language works, to look at the grammar, which is this file. That's up to date. That's basically the grammar for the parser, and the parser is generated from. Other than that, well, you can always just maybe ping me on Discord, or I'm in the technical Factorio Discord server, so my name, I think my, I'm not sure, ping me there, but anyway, I guess nobody wants to use stuff anyway. So this is a circuit description language which compiles down to circuits. Let me actually try compile lock, and there we go. We go over it. So it's compiling, generating an abstract syntax tree, and then compiles it down to an intermediate representation, which is basically a list of combinators. That's the intermediate representation, and then it generates a blueprint. This is the blueprint itself, and then it outputs the blueprint string. So that's one tool I wrote. And I also there's this crazy guy who, yeah, I programmed Factorio from scratch, multi-thread with multiplayer and mod support by Variant Programmer, which is crazy. That's really, like, this is not the original game. He basically wrote his own Factorio. You might see that the graphics are the same, except for the modded cities. And that's because, as he described it, I guess you should just read it yourself, basically. He just loads the mods, which includes the base mod, which is basically the game. So Factorio, the game, is basically a game engine, and then the game itself is written in Lua, which is the base mod. So, and that's, the source code is available. You can run the base mod yourself. It's Lua code, and that's what he did. You still have to write the whole engine, and I think he took like 6 months working on during lockdown. So probably working like putting quite a lot of hours into it. I'm not gonna do that. I can't spend that much time on it. Okay. So, but at least I thought, well, I can start working on it. Let's just try to load mods. So that's the first thing I did, and let's close the circuit stuff here. So I started. Actually, I wrote the mod loader already. Yeah, syntax highlighting intelligently, please. Come on. There we go. So this is the mod loader. It loads mods, Factorio mods. You give it a core path. Core is like also some Lua stuff. Maybe I should just show you. Second. So if you go to your Factorio folder, first of all, look, I also need to theme. I think common. And this might be different for your platform. This is the Factorio game. See, you have the data here. You have core, which has a couple of Lua libraries. At the moment, if you like looked into modding, you know that there's a data phase. And this is also a variant programmer in his comment. He also described a little bit how he went about. Here, so read that if you're interested in doing stuff like that. There is this. So the modding in Factorio is done with Lua. So Factorio has a very good documentation on what the interfaces are. You can go here, data lifecycle. So okay, first of all, there's a setting stage. So I don't think base mod uses settings. So I think my mod loader can do this phase, this stage, which I think it just runs Lua files and then compiles all the data into this settings data file, which is data format for just key value pairs basically. It's where you define your prototypes, and prototypes are basically templates for creating entities or other stuff like recipes, items, technology. As I already said, I have mods. Go mods. There's data. So this is loaded, and you just extend this table basically with your prototypes. And this is a technology prototype. Then we have recipes, items, and other stuff. The entities, which are then, in this case, it's a constant combinator, steel chest, stuff like that. So the base game is defined as that, like this as well, and you can just run that code, Lua code, which is cool. So that's what we do here. We just basically run those files. So it's specified, then data updates, and then data final fixes. So that's what we do here, right? Data Lua updates, fixes. I also run data core. Oh, that's the basically the prototypes defined by core. I'm not really sure what you should describe core as. It's not really a mod, and I'm not sure if that's correct how I do it, but it works for now. So you also need this data loader that I just mentioned here, which basically defines this data table. So I run that, and this lets me actually this loads all the data or all the prototypes from base game. I think like I can also load mods. I haven't tested it too much. And how you would do that is little application here, basically a small tool, which just does that. Of this. So this just creates the mod loader, point it to your game folder. First this one and then base mod. And this is just a mod, right? So it's a big mod though, because it defines the base game. But this also includes all the graphics, so that's one thing Aaron programmer mentioned also. He doesn't have to do any artwork, and that would be out of my scope, like very much. Art, but I wouldn't be able to do like graphics like Factorio have. That's really not my skill. But it's all in the mod, so all in this mod. I can just use it. Obviously, I can't publish that. This is proper, like this is owned by the devs of Factorio that. So you have to use my mod loader with your game you bought, and I can just highly recommend buying it. I think the devs said that they are not really that much concerned about piracy, but it's really worth the money. Really, really worth. Okay. So this tool loads then basically creates a mod loader, gives it the path. You have to run this, otherwise I think you will get a warning if you have login enabled. But you have to thing like orders the mods by dependencies. So we will have them sorted like that, so they can be run in the right order, and it will also check that all dependencies are met. I think it wasn't just a blob of code, which just also checks if there are cycles in your dependency graph. And so, and by the way, if you want to look at the code, head over to the GitHub Factorio. This is core we're working on. You can see I have a couple of crates already. Maybe since I already let's finish talking about my tool here. Basically it runs the data stage, and this gives us the data table that we just that basically it just runs, it creates a Lua interpreter, and I use please don't stone me for unsafe. So this creates a Lua interpreter. I'm using, I think it's mlua. Yeah, it's mlua. Pretty great, works well. I actually, so I set it to run, like, use Lua 5.2, which is the version Factorio uses. But I know from Variant Programmer, from this guy who wrote the really crazy his own game engine, he uses Lua JIT. So that's just-in-time compiled Lua. So basically, when you run the Lua code, it will compile it to machine code. So, and I think he says it's also very much faster. Yeah, so that's cool. I'm just using the Lua 5.2 here, but with mLua you can also do a JIT. It supports several Lua. That's cool. Okay, this creates a Lua interpreter. You need unsafe here because unsafe new of mLua actually gives you some features of Lua that Factorio needs. I would like to work around this, not using unsafe, because I really don't know how to uphold those. And if you use unsafe, you as the programmer, the Rust programmer, should make sure that it's actually not unsafe. Compiler can do that. But I don't know what the invariants here are, what I have to look out for. I'm just loading arbitrary Lua code, basically the game mods. I don't know if, so in this case I should actually mark this whole method as unsafe. But I will work on this anyway. I will probably have some more helper structs and stuff for Lua, which might then actually fix the unsafety. I'm not sure. But I will look into that. Or maybe if you're interested in doing that, let me out. Okay, so this runs the data stage in, like the mods are sorted. We know in which order to run them. We create, you have to have a couple of tables in your environment, basically mods and settings. Globals, I don't populate anything there right now, so but whatever. No, I put the mods and settings into globals, and then I just run the files. There's just a couple of Lua utils I have to run the files, and then we get all the prototypes. And this tool actually is a little, this is just a small Lua curses application to actually show the prototypes, and I need to improve on that tool as well. Kind of useful, but it only shows up to a certain depth, because after that it just becomes unusable. Because there are a lot of prototypes, so it's a lot of data actually, and it tries to load it all at once. Actually, you should only load data that you actually want to display, which I will implement in here. I think it's just compiling in the back right now. Hopefully that doesn't affect it too much. Whatever. Okay, so that's that. So we can actually load prototypes. So far we have them as a what is a value here? Well, that's just something that is a Lua value, not statically typed, so it can be anything. It can be a table string, number, integer, boolean, or the. And actually I have this from Lua value trait, which I implement on types that can be, well, anything that can be created from a Lua value from our mLua operator. So I don't want to have this dynamic stuff, right? This value type. It's useful sometimes, but I wanted to have, let me actually quickly check if it's done yet. Compiling. I wanted to have the prototypes actually converted to data, to Rust structs. So, and I have this from Lua value trait, so I only have to implement that for all the prototypes there are. And for that is this data, so this defines the from thinking. This defines the trait from Lua value. There's also a trait from Lua table, and it implements them for a couple of types, for the integers, for floats, bools, nil is basically the empty tuple. So we can do that. Then we can upon that, right? I have other ones here as well. I have vectors and colors. This is the dynamic. Right? So okay, enough talking about that. And then there's I created a derived. So we have a derive macro to actually let's just show it in action. Where are the prototype? The prototype. Okay, as you can see, there are a lot of prototypes. Those are generated, or those are the prototypes available in game, and I just actually went to the information about it, and you can go to the prototype view. I just saved this HTML and then wrote a small Python script to parse it. Wasn't perfect, but it worked. So now we have all those structs. Those are generated, and then I fix them up a little bit. And I can just now derive from Lua table, and what that does is just, well, from the Lua table load those values. And I also have a prototype derive mark, because I need a prototype trait that is here. So we have a prototype trait, and this is what I'm still working on. So I was thinking, so I need to use an entity component system, and I was thinking to loading those prototypes as resource, which so this is actually for every prototype. It's kind of confusing. For every prototype that exists here, you can have multiple things that actually use that prototype. Right? For example, there are probably multiple achievements, and there are multiple ambient sounds. So, and those I want to load in here. And then there's kind of inheritance involved, prototypes, handle that, yeah. But I think I'm gonna start working on that. So I'm loading those as resources. A resource is just a global kind of variable in a CS. So let's start looking at how we actually do. I kind of want to have the prototypes loaded into the game engine so that we can, for example, just, oh, that's a smelting recipe, right? And then I also want to be able to instantiate entity. Entity is actually a prototype. For example, we have here entity with health. That's an entity. So they have a couple of properties here. And as you can see, and as I just mentioned, there's also inheritance involved. We have an entity with health. Never mind. Okay, so and this adds this. So the entity with health has these properties, but then everything that's an entity with health is also an entity. Those are separate structs though in code. So we kind of need to load all that, which is, oh, there. So back to the prototype, to my little tool I wrote to actually visualize the prototypes, because it just finished compiling it. So, for example, I can just open the accumulator here and see the prototype, the properties of a accumulator. You might wonder, why is the accumulator in there? So the first one is the prototype itself. The second one here is actually instantiation of that prototype. If you want to mod the game, you can create your own accumulator and stuff like that. For example, armor, there should be there's heavy, light, modular, power armor, so you have those instantiations of prototypes. And yeah, well, they then define their icons. And then we can use those icons. And while this tool is just a little helper I built, see there are two cars down here. Cargo wagon. So, but you can also go to the wiki or to the Lua API document. Okay, so about the inheritance, I was thinking. So each, or actually, I think I actually solved this already. So I wrote this derived prototype, and you can actually tell it what it derives from. So the accumulator derives from an entity which is just in here, right? Here. And this should be defined in like this should be checked by the compiler at compile time. But it's a type argument, a type parameter to the trait accumulator. So you have to basically, I would have to implement prototype or accumulator, and then I have to specify as type. But I just have this. So, okay, let me try to remember. So we have the inheritance. This, and I have kind of a visitor pattern over that, which we had a couple of weeks ago that I wrote this. And yeah, the load into, which was using Legion. So I wanted to use Legion as an ECS, and it loads it into a resource. But no, let's go to the what game engine are we using? I thought I wanted to try out Bevy. So usually I'm a fan of Amethyst because it has a lot of stuff. And I think Bevy sounds pretty cool too because it's much easier. Amethyst is kind of very verbose and very complicated. So I want to try Bevy, and it has its own easy. Actually, here, look at that. And Bevy has also supports resources. Again, resources are global data. So I guess I'm gonna tackle this from starting this. I think I explained enough here. So yeah, and if you have any questions, also I'm trying to check the chat, but again, I'm not really streaming that often at all. I might just mess up and read your messages. So, but just try to ask. Let's go to let's close. Let's go to main. Okay. Let's remove that. I would like to use Legion, but Bevy has its own easy. And I think this also looked nice. I just read the Bevy book. It's not very comprehensive right now, but looks pretty straightforward to use. And so yeah, also I'm just doing all this Factorio rewriting in Rust just to learn a little bit more about how you actually write games. Because usually tutorials like handle maybe Tetris and but not really to write something on the scale of Factorio. So I want to learn how to use this prototype-based programming for games. I want to learn more about how they use that with CS and like also big motivation for do this. Anyway, let's start using Bevy here. And I think they kind of recommend using the Git, using it from Git because it's being developed that fast. And actually, I might just clone it. Yeah, I think I just clone it because then I can also change stuff around if I need something in the engine changed. And I can open the code easily, have a look at it, and that's also, I can only recommend if you are trying to use a tool and it's, well, documentation sometimes it's not the priority of many programmers, although good documentation is important. But take a look at the code, don't be afraid. It's most of there's a lot of good things about open source, and one thing is that you can just look at the code. You should really use that. Okay, so that's cloning. Divi. So, and then you can just have. So, and also just in the chat or comments or whatever, I don't streams have comments. But, let me know if font needs to be larger. Still telling me that the stream quality is good and I have a higher bitrate now, so I hope it works. Really sorry if not. I can't change my internet connection, unfortunately. So, two up and then Bevy. It cloned already. I guess I'm just gonna build it right now. Oh. Okay, that can run. Hopefully, hopefully my Rust can be quite heavy on your system resources. I think it's just already. I think building Bevy right now. Downloading dependencies. Pull out Bevy again. I'm gonna open this on my second screen. Unfortunately, you can't see my second screen. Okay, so what? I have no idea at all. About what? Don't you have any idea? Probably about what I'm doing here. So I'm just rewriting Factorio in Rust, obviously. No, really, I'm doing that, but for fun, not really. Not really. Not really to make any sense or something. I'm just trying to write a Factorio game in G. Oh, okay, so now my stream is. So now my stream doesn't work anymore. Okay. It's probably because Rust is compiled. Maybe it will get better in a second. Yeah, I think it should be fine. So I'm writing Factorio in Rust. That's what. Let's get Bevy going. And this is like if you want to write games in Rust, this try it out. It can be a lot of fun. So I have done this. Let's just follow the book here. I don't need to set up. I really don't like having preludes. So basically a prelude is, this will import all the well, Rust draws the screen by basically. Yeah, okay, I don't know. Rust, you can draw to screen in Rust with basically any engine you want to use. I'm using Bevy, and Bevy uses, I think it uses WGPU, which also allows you to use it in the browser, so you can run your games in browser. But it really depends on what game engine you use. So if you use Bevy, it will use winit. That's another crate to create a window, and then you can kind of draw to that. Like if you really want to get started, there's also another great game engine, and it's really very minimal and very easy to use, which is called GG Easy. And there you can actually tell it to basically you have this draw function, and then you can just tell it graphics clear. This will clear your screen or your window, and you can probably just draw sprites into it. So that's probably the easiest way to do. How it works with something more involved like Bevy, which uses an ECS that lives in a world, and an entity is a collection of components. So that's the ECS pattern, and there you would would attach basically a component to that entity that tells the engine how to render it. And for example, position and what sprite to use. And that renders it to screen. But we're really not that far yet, so I probably won't show anything rendered on screen soon. So I'm just trying to get started here, really. But yeah, okay, let's continue with setting up Bevy. Okay. Yes. There we go. So, okay, as I said, I don't like preludes, but okay. Just copy that. So, and this is my kind of main here. I just set up a .env is a crate I use a lot of times. It just loads environment. This just loads environment variables from a file. So, and then with the environment variable, I can set the logging. It's just all my programs have those two lines, and then I call this method and handle error printing here. Yeah, I'm this here, but anyway. And we already load the data prototypes here, and so I guess we can keep that. It kind of worked, so let's just start with the Bevy and just plug it in here. We don't want to waste any more time here. Okay, so. So yeah, see, with the prelude, I don't know what that's importing. So actually, it's just importing the app probably. Just gonna do that. If I can get auto completion. Okay, it's in app. And I don't like the prelude. Okay, so that doesn't look like it does a lot of things. Okay, so this explains how ECS work. So ECS is the Entity Component System, or entities, components, and systems because that's what it consists of. So, as I mentioned earlier, entities are basically a collection of components, and you have a lot of entities in your world, basically, which is basically your game world. And then you run systems over those entities. Those systems work on the components. Yeah, let's maybe, how does rendering in Bevy work? No idea. Actually, maybe I should have researched more before doing stuff. I think there's a default. There are kind of plugins which are a collection of systems, and there's this default. Just gonna copy this. This default plugins, I think, includes stuff to render stuff to the screen, actually. But actually, I have never used Bevy, so I don't know. I mean, okay. No, I think. Yeah, I don't. Why am I not getting any autocomplete? But I guess if you want to try Bevy, just get the prelude, but everything from there. Don't have to worry about the imports. I like to do that. So in systems in Bevy, I know from Amethyst they use specs, or change specs is another ECS in Rust. They're switching to Legion, which is also an ECS in Rust, and their systems are basically structs, and you implement a system on that struct then and define how the system works. In Bevy, systems are generated from functions, so I will just create, let's get a add stuff. Let's just call it add stuff. So systems in Bevy are just functions. Just gonna define that here. Okay. And I need okay. Yeah, I'm gonna just open the documentation on the second screen now. Too much of switching around. Okay, and then you convert this to a system by calling system, not system. Let's just follow the tutorial. Actually, I want to run to check in the background already, because unfortunately this this Rastory core takes very long to compile, so it might actually be a problem. I might fix that maybe later. Okay, so I guess so. Yeah, IntelliJ is now complaining that system doesn't exist because add stuff is just a method, and the Bevy book also goes over that. This method, I actually should maybe pull it up to screen. This system method is one second. So you call a method on this method, because in Rust methods are just data too. So you could also imagine that this is actually a hello world, and then it calls system on that, and that system method is defined by Bevy. That's done through a extension trait. That's the kind of a thing you do in Rust. You can define your own trait with new methods, and then you implement that trait for types that already exist, for example, for the methods. Right one though. This doesn't have a system method. I think it's not. How? Okay, let's. So I guess the extension trait is in the prelude somewhere, so let's just have a look here. Maybe I should compile on another machine. Oh yeah, here it is. So that's the. This is the extension trait I think that I have. So instead of just importing the prelude and with that. Wait. Oh, this is. Wait until I have to compile it. Yeah, maybe not. Okay. And so this extension trait should give us this method. Although I read earlier about how Bevy works, really forgot. I have that book open. Okay, so we have defined a system. We need components, and I think I will just make. Every prototype we have as a component, because well, although not all prototypes are really used for entities. For example, recipes are not entities. I think, like for example, let's actually have a look at ent. Actually, that might not be a good way to do this. Because then we have kind of an entity component. That's probably not the way to do it. But for example, we could then for every entity just have the vision box. I guess there's also a sprite somewhere. Maybe. So I'm just sprite for a entity is defined. I guess it's not an icon. I mean, there are sounds in here. So, okay. So, because then if we have those prototype, what is structs that actually also contain the prototype data, if we have them attached as components to the entities, we could render them, for example. In prototype. That doesn't make much sense. The prototype stuff, that there are types to, for example, contain sprites for each orientation thing. I have this big file here which contains all the possible Factorio types, and there's, for example, a animation. This well, basically sprites. But the question is, where's that used? So just search for it. And this, like this type stuff and all the prototypes, this will require a lot of cleanups. Okay, yeah, let's just look at, yeah, okay. Oh. So the accumulator, for example, has animations just in the accumulator. So maybe there is no else rendered. Else are animated. Okay, so I guess it makes sense. Like labs, for example, need an off and on animation, and the accumulator needs a charging and discharging animation. But I would rather than actually have other components. For example, I would have a component animation, and then I attach that component, an animation component with the charging animation to that entity while it's charging, and then I detach that component from the entity later. Maybe it doesn't make sense to have the prototypes as component. That sounds complicated. Maybe let's attach the animation. Let's get an animation and a position, which is basically a vector. Let's get components. I'll just create them in here. Okay. And get the types. So we can get the animation here. We will make this. I don't think in specs you have to implement a trait if you want to make it make something a component. But I don't think that's the case with Bevy. I think you can just have components, normal Rust structs. So our animation type, this type here is actually a, and the same for our position. And for positions, I use an algebra, which has a vector type and also a position type, where position is just a vector. It's just and algebra is also very, very good crate I use it a lot actually. Also, whenever you need kind of something that has XML, it comes with all the fancy stuff you kind of want to have. You can like all the math stuff, and actually, I probably don't know what half the stuff is, but sometimes like rotation matrix and first first read Wikipedia what rotation matrix is, and then but yeah, and it's very good documented. So if you want to work with something that is a vector and algebra is the go. And it also, I think it's part of the um, thing called DimForge. Yeah, so basically DimForge is the organization that also provide nCollide, which has collision detection, which we probably will need because even if you want to check if, for example, the mouse cursor interacts with a, it also have a physics engine. So, and algebra, very good. Not really making progress. not a lot. So, okay, so our components will be position and sprites. And I have an idea that Factorio has, but I want to render combinators. So maybe let's get those in. How can I do that? So let's imagine I want to render a blueprint of combinators. So YouTube is telling me again that it's that my stream quality is bad. Sorry for that. And I'm not really sure yet about the connection between. So I have no idea how Factorio is implemented itself, like the engine, and I am not sure about the connection between what you have in a blueprint and actually what the game object. So in Factorio you have in the blueprints you have those entity structs which basically contain everything possible. But the most important thing is probably the name and the position. And maybe the orientation. And the name is the name of the not of the prototype, but of the thing that is that prototype. Okay. Hmm. Yes. This is still unresolved. Actually, let's compile everything. Okay. Been streaming for an hour and I haven't even started yet. Maybe I should prepare better. Anyway, let's go back to Heavy. Okay, so there are two kinds of systems in Bevy. A startup system and normal system. And I think we already have kind of a system from the default plugins that renders. We'll probably look into how that works. Okay. Okay, so that's just an example game. A startup system setup. And we probably want to have kind of a similar setup system. Actually, setup is probably also a better name than stuff. Because we also need the asset server. So assets are basically stuff out as game like sprites and sounds. This commands thing here allows you to add I think. Okay, so it's spawn. I think spawn. I'm not sure, so I will have a look. Well, this is world spawn right now. Once the page loads. Create an entity with certain components, yeah. But actually we have command. Not sure if that's different. No, it's just a dynamic bundle. Seems to add bundles. Okay. So I guess we need those two. Get a UI for free. That's cool. Hmm. This also creates pedal, like with pedal. What's with? Yeah, unfortunately, no document. What is creating a component? Did I miss something? Okay, oh, I guess so. Commands is probably more like a builder's kind of thing. A queue of commands to run on the current world and resource. Okay. So, and I guess if you say spawn, but it's spawning a bunch. Why is that? Type collection of components. So okay, so it's basically a collection of components. think the sprite bundle then just contains components for example, for the position and sprite. So I guess we don't need anything else actually. So, okay. Okay, spawn does add entities. I guess that makes sense. Then with the with method, you can add more components to that. Interesting. Where is the sprite? The sprite bundle. Okay, yes. Where does this come from? It can only come from the prelude. No such thing as a sprite bundle. Maybe the example is not 8. No, let's read documentation. Oh. Very, very interesting. So Bevi is quite new and in development, so seems to be a bundle. And it still exists. So it's probably just renamed right components. Because it's less confusing as bundle. Amethyst has also things like bundles, but they are completely different thing. So the sprite bundle might have a little bit too confusing. Where's sprite components actually right entity? And so yeah, the example is maybe not. Or maybe it is, because the Git is actually the example I'm looking at is from the master branch, and this is 0.30, and so it might be changed it the other way around. I'm just opening the code that earlier. It's sometimes this way to know is just to look at code itself. Yeah, sprite bundle. It's actually, yeah, okay, they named it from sprite component, new sprite bundle. And the example is actually correct, and the documentation is just not up to date with the master branch, obviously, because the documentation is for the last release. So, okay. So I must say, sprite components would be clearer what it is, but for now. This sprite. Okay. Yeah, okay, so see you later. And I really take a look at Rust. It's also an awesome programming language for also stuff, not only game. It, while it's hard to learn, it's helps you save a lot of time because the compiler will try. Okay. And I also thank you for having me here because I didn't expect anyone watching, so I guess that's already a good start. And yeah, see you with that. Hey. Okay, so we created. What's the camera bundle doing? It's probably to. Oh yeah, okay. Well, probably creating a camera. Yeah, that's a camera. Projection. Name window. Also, you can render to multiple windows. Okay. And keeps track of the entities, which is good. Because that might mean that it actually doesn't try to render anything else. Although it might not, I'm not sure. Because actually, like I found out, figuring out which entities are visible is not that easy. So a transform is the position and kind of a couple of other properties like a translation, which is the position, rotation, and scale. They have very mad. Oh, they don't use in algebra? Oh, that's kind of sad. I wanted to use an algebra for everything. But um, they use GLAM. So I guess that's another. Oh, so that's another math library, I guess. Then we might switch to that. I used an algebra everywhere, so we might switch to that. Yeah. Or you can just have conversion between them. And then that's probably handling pay, you stuff. I'm not sure how materials work. I have never used materials that much. Color material. Okay. Oh, okay, so I guess we don't even have to give it a material because it will fill out the rest. Also, so we just need that. Just need to give it a transform. And sprite. How is that? It usually the sprite has a texture. Oh, it has a texture in here. A color material from. So maybe we have to use the stuff, material stuff. Go back to the example. That means. Okay, so we need this assets color material. Or maybe not a color material, but another material. Like this assets thing is probably a storage for assets. But I don't want a color material. Well, it is color. I think it's probably import. If not, the compiler will tell me. So they do it by materials. So maybe we should have a look at the assets. Yeah, so this you can add an asset and then you get the handler. And that's so that you don't have to load stuff twice, I guess. But so it might also send it to the GPU or so they convert the color into a color material. And I want to use a texture actually. But I have to give it a handle to a texture. So I probably also need a assets texture. Because that's the way I get handles, right? So let's get a mute textures. Yes. And rest mute is just a resource here. Yes, texture. Just import a prelude. Heavy render texture. Let's have a look. They probably have somewhere. Hmm. Because we can also get a handle by I'm not sure what the difference between assets and assets are. Hmm. Oh yeah, we have this. And load. Seems easy. Let's also get handle. E. Get handle. Okay, so you can get the handle after you loaded them. Or you can just load them. So I guess I'm just gonna load the texture. So this is actually material. Then then we need mute materials. It's a res mute assets material. Well, so that we get the handle, we add. Oh no, wait. We need to create the materials, and we create that from converting ink from a texture. So texture.into basically, and we get the texture from the assets. Asset server dot is this dot load. Dot server dot load. This question is does this load? Yeah. So you returns the handle T, and then I guess knows, well, the compiler can derive. In this case, it might not know that I want to load the texture actually. So maybe need to do this here. Need to give it a hint because it doesn't know what I want to have here and pick to a material. Okay. And we actually want to do this for all the kind of accumulators and what not we have. So let's look at comparison. Because for now I would be fine with just rendering combinators. And actually doesn't have it. Oh wait, it's a combi. So this doesn't have any sprites that we want. Actually, like it doesn't have the sprite here of the combinator itself, just for like symbols. But if we go to combinator, and as you can see, I didn't derive. Oh yeah, okay. This has, it even has sprites for the LEDs on the combinator. Okay, so in a game, so I'm just interested in rendering like a blueprint of combinators for now. But if the game was running, you wanted to actually have this update from, so basically your entity. Wait, this is probably not correct. Okay. So your entity has kind of this combinator prototype data, and stuff like this would probably split this up, but this will be components attached to the entity. Then I want to have, for example, a sprite for the sprite 4-ways. The sprite 4-way is basically just something that can be that's just 4 sprites for each orientation. And then I want to have a system run over the entities that have sprite 4-ways and render them. But then again, sometimes you render them differently depending on what state something is in. For example, accumulator will render different right when charging, so it might make sense to not have this stuff as a component, but to maybe have it attached to the entity, but only just as data, and then you run over all the entities and you look at what you actually want to render and put that into the sprite bundle thingy. Interesting. Okay. You know what we should do is we have this stuff here. Let's load a blueprint. Actually, that's oh well, the stuff doesn't compile right now, so it's fixed and really create prototypes more. I removed lead because I'm too late to fix those load into the thingies, because they will change anyway. I will just have type here. And I would just want to get a sample blueprint. The only way I would do this right now is by compiling. Well, I might actually have one. They only have like weird with lamps and speakers. So I just want to compare my blog. So I have this clock circuit example. Okay, I think we need to probably find out what kind prototype combinator. I think that inherits from probably and that fixes that. Just want to get the blueprint string. So my plan is get a blueprint string and add the entities from the blueprint string to our ECS. And then just try to render them. Like just get this like a very little prototype. Because that would be actually a nice tool already to be able to render blueprint. Oh yeah, we don't need this input block here anymore, because prototype is derived macro. So if you have time to learn about how proc macros work, write your own derived macros and stuff like that. Pretty useful to do that. So there's a couple of things to do that, tools to help you. Let me just go on a quick excursion here. So I have this data derived, right? So data basically is that's what from the traits, right? And then So first of all, proc macro 2 is a, maybe that's too much of a excursion here, but the proc macro is a macro in Rust where you get fed in. For example, this is a derive, right? This says derive debug for this struct here, but this says derive debug for this struct function that's added to the compiler, which takes the token stream of this struct and outputs the implementation for, or just another token stream really, but in reality the implementation for the debug trade. So you just output the token stream and just Darling is definitely a good crate to help with that. But I guess that's really out of scope right now to go over how proc macros work. Yeah, I guess I just wanted to. Oh my god. Can I compile though? Might be able to just run this program here. Fail to resolve Bevy. Oh, I think I added it to the here. I think core will need Bevy. Just want to prototype things. Just to remain right now. And it's compiling everything. Christ. Yeah, sorry for probably lagging right now, buffering because of compiling everything. I will fix that by just getting another machine to compile for me. Yeah, it's compiling everything, so. Okay, so basically, we can already make stuff. So I have this blueprint stuff here. We can just decode blueprints. Okay, so first we load all the game prototypes. And let's get the blueprint going. Code. Oh no, I need envelope. Yeah. So envelope is just a thing that contains the blueprint or a blueprint book. And we just would pass it the blueprint string. And we're just gonna unwrap. No, we could just return the error, and this should give us the blueprint once we can actually get it. I mean, I could definitely also just start the game and make one, but I guess that's probably even a worse idea than. Well, maybe it's not that bad as compiling that much. I don't know. Anyway. So let's just imagine we got the blueprint. Oh yeah, first of all, I only want to return the blueprint. And otherwise, I'll just... What error type do we? Yeah, let's just panic. A blueprint. Obviously, you should actually return an error, but anyway. Hmm. And blueprint consists of entities. How do you get this into the setup command? Into the setup system. Because you kind of want to create a system with that blueprint, right? Hmm. I also don't know what a for each inquiry system is, but I guess we could just implement system ourselves. But that sounds. Hmm. So I want to pass this the blueprint. How this would work with specs and amethyst. Say you have a system descriptor, but startups. We should let me try that. Okay, it is also startups. What's this? Oh, I think stages are just states of your game. So maybe the main menu, but I might be wrong. No, this just takes a DIN system. This is way too complicated for me to implement. Wish you could see what. Oh wait, right? Yeah, so this implements the system for func systems. I guess that's the one you get from calling the system method on a function. Okay. Really don't know how to do that. Maybe we have example. It's not very good. Maybe we can give something to the app build thing. Okay, so we can get mute on resources. We just add a resource with the blueprint. Yeah, I think that's probably a good way to do it. Which is blueprint. And here we can get this blueprint. So that loads the with a blueprint from resources. Hey. Okay, so let's just do for entity in print.x forward. Yeah, we need to import blueprint from here. And basically we want such command per entity. So entity is a struct, and we want to match over the name. And then we can then I could just say constant and then do something and stuff like that, but it could also work with prototypes. Have names. So this is the name of the prototype type. I don't know what the proper terms are, but prototypes are named, but that's a type name. And then if you instantiate a prototype, for example, as an entity or as a tile or a recipe, then they also have names. So we need to check for this. But this is actually much more complicated than you have to go actually you need to get the prototype base. Which is like most prototypes inherit from. And that stores the name. Also somehow, at least wiki, from the wiki, I think not every prototype inherits prototype base. Which is kind of weird, but no. But then also from so basically if you look at the data table that we get, it's actually just Okay, so if we look at the data table, we can just go through all the values in the data table, and then those are tables itself too, and if that table then contains this name, then we know that that's a prototype. Right? No, actually. God damn it. So we need the mapping from this name to prototypes that we need to get for them. I guess we can implement that. Let's actually remove this stuff here. I don't need that, right? I want arithmetic combinator. And there's probably also a combinator. And a prototype map is basically this inner table. So if you remember Jesus Christ. Okay, let it come. If you remember, we had this table, which is first prototyped prototype, and then on the second level it's a mapping from the prototype name to the data for that prototype. And that's this inner one. And then there are instant combinator. And then there's probably a decider. Okay. But actually what we have here is not, because in the table, this Lua table that we wanna pass is also this stuff. So I don't think that's correct. So let's just delete that. Data stage already converts the Lua table. I don't think that's how we should do it. I think should read once I come on IntelliJ, please. Oh my. And definitely need a solution for compiling stuff, because I think that's too much for the system. Yeah, at least we're not out of memory yet. But still IntelliJ is frozen. Oh, I have time. Oh, there we go. So see, it takes any t, which is a from Lua value, and then already converts it. And that's kind of what we have to do, because this Lua table here only it depends on the lifetime of the Lua interpreter, because those values only live in the Lua interpreter. But what we could also do here is to have kind of a kind of struct that collects the prototypes and into the appropriate data structures that we need to access them. So already handling the inheritance and stuff like that. That's probably what we need to do here. So it's probably gonna be a struct prototypes that also implements them from Lua value. Oh yeah, I actually wanted to load it into the resource. I wanted to load one such thing per prototype as what did I delete here just now? If we get this, I mean, this is the... Okay, yeah, this might actually work. We also need to have the... So we need at least all prototypes that, for example, the arithmetic combinator needs. That's first this prototype, and then the ones it depends on. That's probably entity with health type. Then again, combinator. And also entity with health doesn't probably exist. Well, they do exist, but not in the data table, because you can't instantiate them. I'm not sure if I actually handle that right now. So this needs to go. Okay, that's the problem though. Okay. Okay. So that's kind of complicated. We need some way to actually load that. So if we load a arithmetic combinator, we actually also need to load the entity with health from that same table. But store it into a different... Yeah, I guess we can do this. So let's go prototype base. Start with that. This will hold everything from thingies that can be that are basically prototypes. Any anything that is a comes from a prototype that inherits prototype base. And it's an a entity. I think that's the inheritance here. And then entity with health. And I guess then it's a combination, and we get the arithmetic designer combinator. Okay. So from implement from table for prototypes. Have that trait in here from, yeah. Ah, no, we have to. We don't need that anymore, so this is the trait. And it's, yeah, from Lua table. So if you implement from Lua table for something, then you will also get automatically the from Lua value. And this just needs this method. And it's an mlua table. So that's a table from Lua, from the Lua mlua interpreter, and it also contains lifetimes. So the mlua still compiling. Jesus Christ. So yeah. See, this is as a lifetime of the Lua interpreter. So So basically what that means is it contains stuff that has a lifetime, is in a mod loader in this data station method. So, but you don't have to write this explicitly here. Okay, what error is that we actually need there? Data. I don't think. Well, let's specify that here. And I'm not importing that because we already have error imported, but that's a different error. Okay, so this is fine. So now as I just showed you, this has a pairs method. So so basically, and you can give it 2 type parameters, which is, it's kind of like the from Lua value I have, similar, but from mlua. So I think this is probably implemented for string. So we can, the keys will be strings, and the values for the, I mean, I would show you if this would. Values are mlua tables, or this is the proto. How would I name this? Let's call it key and value for now. Reason we can always change this. Okay. And so the key is basically the root name. So the first thing we want to load here, I think. Yeah, basically we have to get the key. Jesus Christ, that's gonna be complicated. So if the key is, for example, decider combinator, we wanna have a look at that, and actually we need to get the type somehow. Maybe I just write a match for the key right now. Let's say we have arithmetic combinator. It's also with a dash. And I'm just like prototyping this right now, so probably this will be auto-generated with another macro later on. Okay, let's just give it a reference to. Oh, so let's mute prototypes. Does the prototype map come from? Okay, that's just a hash map. Everything is default. We can have default on here. If it's an arithmetic combinator, we're gonna get a mutable reference to prototypes dot what we do with the reference, you will see in a second. Yeah, you will see in a second. I think, yes. Yeah, I think that might work actually. It's just to do for the rest. For that proton is that. So now we have a mutable reference to the prototype map with the correct type, so basically knows. Oh wait. Because if I add another one, right, let me show later. So decider. This doesn't work because, well, those two branches, or those two match thingies have different types. So maybe this is. Let's have a look at Bevy about the resource thingy they have. We could, like I actually planned to do initially, create a prototype resource, add that to the ECS. Yeah, I guess that's for another time because I'm getting quite hungry. So maybe I will try to figure something out, and so maybe I will do a stream once a week, maybe more often, depending on how that works out. Oh hi. But I need to figure out how do we load the prototypes into this prototype resource. Then it depends on the actual prototype type, so that we basically get all the prototypes into the ECS, and then at some point we can just ask then, like, give me the sprites for that thing. But I think I really won't figure it out tonight, and But that's the way I will continue, like implement that, kind of load the prototypes into CS, and then try to render them. And hopefully getting a blueprint renderer for these combinators going. Oh, and by the way, so one thing I want to do is so Bevy works with WebAssembly, and I think all those stuff should also work with WebAssembly. So maybe we can get the circuit compiler working in the browser and then also render the stuff in the browser. And well, I guess that's for another time. So I will think about how I want to do this. But I think we will have one resource per prototype that holds everything that uses that prototype. Yeah, I guess that's how we're gonna do it. Okay, anyway, I guess I'm gonna end the stream here, so if I guess it's long enough. I will stream at least what day is today? Today is Wednesday. There's also other stuff I'm working on, which is not Factorio related, but also with Rust. I might stream that. That's basically crypto stuff, but I'm not sure yet. If someone is interested, I guess let me know. But I want to stream the Factorio stuff because that's kind of what I do in my free time. Program tools for it. Okay, well then I guess thank you for watching, and I will stream, and I might work in the meantime, but on this. But yeah, we will see. Okay, so bye.